So, thanks for organising this session. It's been very interesting. So, what I want to talk about today is about using uh, computational methods, using genetic algorithms to think as a part of a reflective process, a part of learning about creative practice. So, thinking about ways in which practitioners in the arts can use code, particularly writing fitness functions, and then examining the outputs from that code as a way of reflecting on that creative practice and providing inspiration for developing it further. So what do we do when we want to get better at some creative practice like writing literature, composing music, or making art? Well, one thing we're often encouraged to do is to articulate, to talk about it, to write about it. So we're asked to articulate what processes and techniques we used, where we got our inspiration from. We're asked to articulate what the intended meaning is or emotion is that we're trying to transmit to the audience through our work. So typically this articulation has been done in writing, and that's been critiqued. There's a famous quote that's ascribed to various people. Unknown origin, writing about music is like dancing about architecture. But nonetheless, we still encourage people to write and talk about the music they're making, or the art they're making, or the literature they're writing, and so on. So what if we were to do this sort of articulation in code rather than in writing? And code's a very unforgiving medium. So perhaps by trying to articulate our human practices through code, we have to be very careful and articulate our assumptions very carefully, and so on. So that's what I've been thinking about and what I've been trying to do here. So, if we are going to articulate this through code, how might we do it, and why might we do it? I don't want to think of this as being creating a machine that does your creative work for you. I'm not interested for the purpose of this work in this sort of end-to-end process of taking a corpus of work that someone's done and trying to pastiche it. I'm interested in someone working carefully to use the code to understand what they're doing. So that might be in the form of writing algorithms that try and create something that sounds or looks or whatever like the stuff that they produce. It might be about understanding that product statistically, so thinking about the distribution of notes, for example, in music. It might not be about writing generative code. It might be about writing code for optimization. It might be about writing fitness functions where the optimum that's being searched for is something that's similar to your practice. Or it might be about learning not from whole pieces of work, but from specific fragments that illustrate a technique that you're interested in. So let's have a think of an example. So I've been applying this to my own practice in musical composition, and here's an excerpt from one part of a piece that I wrote a few years ago. And this illustrates something that I think is quite characteristic of the music that I write, which is that there's lots of these lines where the intervals, the differences between the notes, varies quite a lot. So there's a big leap down there, a small leap down there, a big leap up there, a small leap there, and a bit further along there's lots of smaller intervals being explored, and so on. So across this there'll be that kind of randomness of intervals. It's that distribution is quite the intervals are distributed quite uniformly. There's not a bias towards one, and the aim of this is to create this music that doesn't really have a center, that doesn't have a particular tonal focus. Now, just play an excerpt from this to give you an idea of what this sounds like. So this is something, that I've written as a human musician. How might I use, if I wanted to replicate that on a computer, replicate that technique, that style of work, how could I do it? Well, I could write some code that counts the number of times an interval's been used, and then the next instruction in the code is to pick the least used one. I might have some system already that generates notes based on a statistical distribution, and I say I want it to choose those intervals randomly from a uniform distribution. I might have an optimization approach. I might write a fitness function that's at its optimum when the number of examples of each interval is uniformly distributed. So it might be something like the Gini coefficient or some measure like that measures uniformity within a set of numbers. Or I might provide examples from those patterns, those micro patterns, and feed them into a GAN and examine the output. So there's different ways of using code to generate that sort of material. Why might I care about these different kinds of generation techniques? Well, optimization has an advantage over algorithmic generation in that it's easier to combine different techniques. You can put different techniques together into a fitness function. Optimization has advantages over other techniques in that it's possible to combine techniques that operate on different timescales. But algorithmic generation has advantages over optimization in that it's easier to generate material that needs precise placement of lots of individual notes. That's the sort of really tight optimum that optimization is going to find it hard to find. But generally, optimization makes it easier to combine methods that require what we might call different theories to generate. We don't need to provide a basic theory of how we're going to generate material. And finally, learning from a corpus, it has advantages over other techniques in that it can pick up on features that the creator hasn't noticed themselves. So, all these other techniques, I'm articulating it very carefully myself in the code, whereas if I'm learning from a corpus, it might pick up on things that I don't know about. So there are advantages and disadvantages to all these different methods of work. So just for the last minute or two, I want to talk about a simple realization of this. So this consists of two kinds of code. It consists of generators that produce musical material. So they might, for example, produce a sequence of random notes, a trill where you're alternating between two notes. It might take an existing piece of music and insert gaps into it. And these generators are used to produce an initial population. And then there are drivers which are used to create the fitness function. So there are things like a measure of how melodic a piece of music is, this thing that I talked about earlier, this serialism of intervals, the amount of these trills, these alternating note passages, the number of gaps in. These are all things that I use in my musical practice. And so then these can be put together by a GA that has a population that consists of a sequence of MIDI notes. And then you say which generators you're going to use and which combination of drivers you're going to put together to specify the fitness function. And it's driven by a mutation operator that changes notes to different pitches and notes to rests and so on, and just crossover between sequences of notes. So what happens if we have a generator that generates random notes in even rhythm, put some gaps in it, and the drivers are a combination of retaining those gaps, trying to make the note sequences more melodic, and create more of these alternating trilly sequences between notes? Well, we get something which I think subjectively satisfies all these different aspects of this driver. So I'll just play this as something that's generated by the GA after 800 generations. So that's retained those gaps that were there at the beginning. It's made the random fragments more melodic. It's put in some of these trills and alternations that are part of how I compose music. So why do I care about this, just to finish? Well, I think the act of writing the code is an important part of the process. It's articulating our assumptions, and the end result isn't designed to be used directly, but to provide inspiration. So both the process of writing the code and the process of listening to what the GA produce is part of this reflective process. And this, as I say, is an ongoing project which is looking at how you can use code as a kind of reflective autoethnographic tool to understand creative practice. So I'll finish there. Thank you.